Hi, my name is Kumail Alhamoud. I'm from Saudi Arabia. I'm a first-year PhD student at MIT CSAIL working with Professor Marzia Ghasemi. My main focus is on the generalizability of machine learning systems, and our main goal is to make deep learning systems deployable, reliable, and robust under various distribution shifts. A recent ongoing project I'm very excited to share is about the deployability of machine learning systems in healthcare. And in healthcare, we have a lot of different patients that come from different demographics. And one way to categorize patients is by age. So if you train a neural network model on a specific subpopulation or a specific age group, you hope that that neural network model is able to also work well on another age group. So in this experiment, we train one model on younger patients on some data set of skin lesion classification. And then we test the model on older patients or on data from older patients. And what we found is that if you train your model on one age group, it is very susceptible to picking up on spurious correlations in the data set. So in this data set, the model just learns that, younger patients, they have a lot of moles, which is the benign label in this data set. And then it over-predicts this label. And this is very dangerous in practice because if you deploy this system in a real-world healthcare setting, you also want it to pick up on the more nuanced diagnoses that are more common with older patients. So we found that this phenomenon happens a lot across different data sets. And just by the way you are constructing your data set, you might have more like a correlation of a particular label with a particular age group, and it's very important to make your model more robust to distribution shifts that arise from different demographics. What we mean by a distribution shift is basically that your training data set is distinct from your test set. So there is a specific dimension in which your training set does not match your test set, and you want a model that generalizes to this unseen test set. So one thing might be that the composition of labels or diagnoses that you have in your training set does not match the test set. And in this specific case, you have many more patients that have the mole label in your training set, but you have a lot more diverse diagnoses in your test set. And this is called a label distribution shift, which is a specific kind of distribution shifts, but we are interested in tackling all of these diverse types of distribution shifts. So the reason why I personally got interested in this is through personal experience. I had a specific medical condition, an emergency actually, and when I went to the ER, the doctors were really struggling to figure out what was going on. And that was the reason why they were struggling is that they saw very few patients throughout their careers that were my age and had those symptoms or combination of symptoms. And I think this tells us something about statistical bias or human bias, which is if you keep seeing the same cases over and over again, this is what you immediately think of. So they were thinking of conditions that had nothing to do with what I had, simply because they never saw a case like the case they were presented with at the time. So my main goal and my main motivation behind doing this kind of work is if we build reliable deep learning systems and train them on as diverse of data sets as possible, maybe these systems can help doctors that are presented with novel cases just by learning from this huge amount of data that we have available. And this will help us accelerate the diagnosis of diverse patients with diverse medical conditions. What we eventually hope to achieve from this project is just a first step towards showcasing the complications that happen in datasets like medical imaging datasets, and to bring the attention of the academic research community to these problems, so that more and more researchers start uncovering the types of distribution shifts that happen in their areas. So this is not necessarily a medical diagnostic issue. It happens all over the machine learning application domains.